want to keep talking about the regression, and we will finish the regression. If you remember, we did an example of regression in which we defined regression as what it is from psychological point of view, and we said that regression was actually created in order to say that we are regressing towards mean, right? And if you remember, we did the example of me being fat and then above the average, what will be the size of my kid and so on. Now, there is also, we can consider another example, because with consideration of the size, there have been lots of other factors, whether McDonald's produce a very nice menu or not, it can affect on the size of the people. But let's consider the height, and when we are considering the height, and we assume that this green line is the average height, okay, the average height of the people, and if the parents are very tall, let's say the parents are here, right? And the probability of, if you want to look at the height of the child will be less than the height of the parents, and it will be somewhere closer to the mean, but still above the mean. Or if the parents are very short, what happens that the kids will be also shorter than the average, and they shorter, but they are still taller than the parents, because we assume that if we go infinity back, everyone was average. Now, if we calculate what happens in the regression is that we have these three values, and if we connect them, if we connect these three values, we will see that we have a line. And if you look at the s-slope of this line, the s-slope of this line is less than 1. Why it is less than 1? And before answering why it is less than 1, what will happen if it is 1?
Do this straight up.
What will happen if the s-slope is 1? Interpret it for me.
Or the slope is 1, then if the line will be now 45 degrees. No?
Interpret it for me. You are describing it. Interpret. A slope is 1 means that line y is equal to x. The angle is 45 degrees. And y is equal to x on value-wise. But interpret it. What does it mean? If the slope of this line is 1, we have, let's say, the height, and we have the child height, and we have the parent's height. What will happen if we have the line with a slope of 1? Sorry? Interpretation.
Well, then we can predict that.
If I know the equation of the line, I can predict, no matter what is the slope. But what will happen if the slope is equal to 1? Anton?
You mean the child height is equal as parent's height?
The child height is the same as parent's height, and we are not regressing towards the mean. If you are tall, your kids will be as tall as you are. What will happen if the slope is greater than 1?
You're going away.
Opposite of regression will happen. You are tall, your kid will be even taller. So it means that we are going away from the mean. But we understand that it's not like that. However, in machine learning, in mathematics, most of the time, what we do is this. We have this data, we try to find this line. And as you can see, we use the word regression as function approximation. We try to find the function. So when we are talking with psychologists, and if you want to use regression, and when you say regression, then there will be big mess up in this communication. Because when we say regression, as a person who works in machine learning or learning algorithm, or as a computer scientist, or even as a mathematician, we mean I have data, fit me the best function. Well, when they mean regression, when the psychologists are talking about regression, they mean this. You are your height is higher than average, your kids will be something in between. We are not talking about functions. We are talking about everything has a tendency towards mean. It's So it means that it is wrong to use the word regression, but it is one of those wrong things that we do it and we accept it. Okay? So we understand the whole story. So we talk about what will happen if the average is greater than 1 or the average is equal to 1. Now historically, in 1800s, regression, when the word regression came out, it was by the means of regression, going towards means. But then machine learning came out, and we started to use it as a fitting a function approximation. So from now on, whenever we call the word regression, we mean function approximation. Now, in order to understand this regression, we have to do, now from machine learning point of view, we have to do another example. So let's do an example, kind of a numerical examples. I have it here. And we use this data, and then we will get back to the slides while we are proceeding. And imagine I want to buy a house, so I have done some investigation. For everything is imaginary, so this is the cost of the house, and this is, let's call area in meter square. And we have, I have written the values like 200. Meter square, 400 meter squares, 600 meter squares, 800 meter squares, and 1000 meter squares, and the prices are $1,000, $2,000, $3,000, $4,000, $5,000, and €6,000. So I wanted to buy a house, so I started to walk in the area and gathering this information. And I have collected several information I found a house which was, I don't know, let's say 80 meters square, and it was 1,000 euro, and then something, let's say 140 meters, and it was 2,000 euro, then 200 meters square, and it was 3,000 euro, and so on. So assume I have these values, okay? And question is this: so these are imaginary numbers, but assume that they are corresponding to my scenario. So the question comes like this, Martin. If you look at this data, and if I find a 500 meter square house, what will be the price of the house?
It will be about 500.
5,000? Why? Why do you say 5,000?
Because if I do the regression, then the line will be kind of.
Why did you say 5,000? What did you look to say that about it's 5,000?
I looked cost at 400.
Yeah, I mean, it seems that if you are looking at the cost for 400 and 600, it's 5,000. This is also 5,000. So let's say for 500 meters square, it is also 5,000. Now, if I try to fit a linear function into this data, it would be maybe something like this. And we understand that if this is the best fit, what is the properties that it has, by the way? How can I consider that this is the best fit?
That's the highest variance.
Smallest variance. Smallest variance.
It has,
Smallest variance.
no, we were using some other terms.
The distance between the line.
The best line is a line which minimizes the errors that they have between the data with the correspondence point on the line. Now, as you can see, if I look at this line, what will be the value for 500 meters squared?
4,000.
It could be, I don't know, if maybe let's say 4,000. Whereas by looking at the values, we were expected to say it is 5,000. Okay? So, the aim, I need to use the board because so then aim is to find the best line. You know what happened? I use a permanent marker. And I'm sure that none of you have.
Try the bottle.
Yeah. Well, we continue with the proper one. And it's YouTube. The aim is to find the best line. What is the best line? Which minimize the error, I'm changing my sentence, the blue one into here. And the question is that what is the error? We can have first order, like absolute error. We can have S squared error. We can have S squashed error. So we can have different type of errors. Typically, we are using S squared error. And S squared error is something like this. I am calculating the perpendicular distances between the points and my line, and I add all these values and I try to find it to minimize it. What will be the minimum value? What will be the minimum value?
0.
The minimum value will be 0. Now, let's do one more example in which we will do the regression. And in this example that we will draw, we will try to minimize actually our function. But we will do a very simple example so we can do the calculation. Is there anyone who has tissues with him or herself? And I need to use this part of the board for this example. It's like that I try to erase this. No tissues? Ah. Thank you.
It might not work.
Might be like a Mr. Bean.
Mr.
Small.
I tried this one on my board in my office. It worked. It worked a little bit, right?
Alcohol is better.
Do you waste alcohol?
Especially at school.
Okay, it worked. Now, in this example that we want to do is this. We will have some sets of data, and I tell you which type of function we want to fit, and then we try to calculate this, minimize this error, and see what is the result. And what we get as a result, we see that it's actually fit very well into the definition of the regression that we have. And the example, let's go here, is this. Imagine we have the points of x and y's as x1, y1, x2, y2 till xn, yn. And if I draw them on a graph, there are points like this. And the question is, find the best line in the form of fx is equal to c. Can you tell me that c is constant? Do you know what is it? What does this function look like? It's a line parallel to the x-axis. So we want to find this line, fx is equal to c, which is the best line. Okay, let's make it kind of a quiz. Find the best line. Because what happens is that we have to come up from this error function to a constraint and say that, okay, this is our function. We have to find the equation of this line. For such a line, what do I need to calculate? What do I need to know in order to draw this line?
Y.
Why?
Average of the y's.
The average of the y's, but it has a name. It has a special name. What do I have to find?
Average.
No.
Maybe standard deviation.
No. In order to draw this line, what do I need to know? Sorry? Main? Mean. I want to draw this line. Can you tell me what is the equation of this line? Fx is equal to c. In order to draw it, what do we need to know?
The c.
The c.
Yes.
So the aim is to calculate the c. We will calculate the c and we find that this is actually the average of the y's. But in order to draw this line, you need to know the value of the c. Now, prove, Eric, that c is the average of the y's. In order to find that c is the average of the line, the y's, we have to look at this S-squared error. Okay, 1 minute. Try to do it. Try to think about it. Establish your error function. How does the error function looks like? It will be something like the summation over i's yi minus c squared. I starts from 1 to n. Now, what do we want to do? We want to minimize this function. Anton, how can I minimize a function in general? Forget about this one. How do you find the minimum value of the function? Suman, how do you find the minimum of a function? Yes, we find the derivatives and we equate it to 0, right? Where we find the derivatives and we equate it to 0. Because this is a parabola, so the shape of the function is something like this. We understand that here the s-slopes are negative, the s-slopes are positive, but because we are talking about s-slope squared, so it's positive number, and there is one place that the slope is 0, and it is the minimum value. S-slope 0 means find the derivative equated to 0. So we find DEC, we find the derivative with respect to C. Y's are the values that we know, C is what we don't know. We want to find the C in a way that it will make this summation minimized. Because y is fixed. I give you the xi and yi. You have them. You cannot change them. You cannot manipulate your data. So we want to find the c. So the question is finding the c. I have to find this one, and I have to equate it to 0. I am sure you remember from series theorems how to find the derivative of a series. It's similar to finding the derivative of an expression. Series will stand as it is. Can you tell me that what is the derivative of this term with respect to C? Let's make it much simpler. What was the derivative of x squared or x to power n? N x to power n minus 1. Let's make it a little bit more complicated. Fx to power n prime. What is the derivative of this one? Let me write it bigger here. What is the derivative of fx to power n prime? If it was x to power n, it was n x to power n minus 1. But if instead of x I have fx, what is the derivative? N multiplied by fx to power f prime of x. So this is the general form. So when we do the same thing in here, it will be, this is my fx, this is my fx. Well, I mean fc, and we do the derivative with respect to c. So it will be 2 multiplied by yi minus c. What is the derivative of this with respect to c? Minus 1. So what we get is 2 minus I can put the 2 out of the summation, so it will be minus 2 multiplied by the summation is equal to 0. I divide both sides by minus 2. So I will get the summation yi minus the summation of c is equal to 0. I put the summation of c on the other side. So what I have the summation of c is equal to the summation of yi. C is constant, right? It is not changing based on I. C is, let's say, number 2. We are not changing it over the I. How many values do I have in the summation? N. Can you tell me that if I am adding C with itself over an iteration of n, what do I get? N multiplied by C. So this is NC. So from here, what can I understand? C is equal to 1 over n summation of yi's. Can you tell me that what is this? 1 over n multiplied by summation of yi's over I. It is average of y's. As we just shouted and said that, okay, C will be average of the y's. C is the average of the y if we want to have it, the error to be minimum. Now, and it is very cool regression, isn't it? It means that we get the minimum if we go towards the average, as we wanted to hear it. Okay, so the whole story is that how can we find the best line? One of the ways is a method which is called hill climbing, and it is like this. I know that I should have a line, y is equal to mx plus b, and I give the value of m and b, the slope and intersection. I draw the line, I calculate the error. And then I change the values, I draw the line, I calculate the value. I do it till I find the best fit. And when I find like the minimum value, I stop. This is one way. Another way is that we are using calculus or a random search to do it. Or we talk with the physicists because we know that they can handle these methods very well. So we have 4 approaches. Now, the quiz here is that which method do we choose? Last one, physicist. Random search. Random search. Anton, which method did you choose? Sorry?
Hill climbing.
Okay, hill climbing. Carpentry. Hill climbing. And Iglis.
Eagles.
Sorry.
I would ask the physicist.
Ask physicist. Okay, Martin, what about you?
Maybe least square error.
Very good method, but which one of these ones is the least square error? Which one is it? Hill climbing, okay. And archaeologists? Random search? Someone? Okay, I would. Random search, said it. Anyone else? What are your names? I don't know.
My name is Henrik.
Henrik.
Yes.
Henrik Turk.
Yes.
Yes. Ulari. Okay, and Henrik Turk. I know Henrik Turk updates his homework quite a lot, so I get lots of worse names. So it's you. The homework once, please. So Ulari, what do you think?
As a physicist,
Physicist Henrik.
I would think the physicist last one maybe the hill climbing.
Hill climbing. 12 people, and none of you chose the calculus, and the answer was calculus. Least square error, derivative, they're all calculus. And hill climbing is not a feasible method. How many values for m and b do you can we give? We understand that we are talking about continuous term. Can you tell me that what are the possibilities? Infinity many. So this is out automatically. We understand that maybe randomly you can give some values and you get something okay. Ask physicists, if you ask them, they will go and ask calculus to do it. So what we do is that random search is a possibility, but I mean computational complexity-wise, it is not very good.
But can computer do calculus? Like
Can a computer calculate a derivative?
for math can.
So can a computer?
Basically yes.
Yes. It's like that. Can human make a robot? You say American can do, but still, can human do it? Yes. So calculus, the computer can do it. We can approximate it, and calculus is the only way that you can do it. Did you want to say anything?
I mean, the physicist thinks that if you have more inputs, then the function gets complicated and you start like climbing down the hill.
No, but you know what physicists will do? Physicists will do this. Physicists will tell you that ask calculus to tell you the line. But I can tell you that the best line is a line which has an increasing slope. Because the tendency of my data is as the area increase, price increase. So this is what we observe. In physics we observe, right? But the person in calculus, they say that you can observe from the slope anyway. I will tell you the best line. And the question is that how can we calculate the best line? Now, in the next slide, we wanted to do the example which I already did. So we have our answers. So we were talking about this error function, the loss function that we calculated in here, right? And it's up to you to use an S-squared. Typically we use S-squared, but if you don't like S-squared error, what you can do is you can use absolute error, which means that yi minus c, you just put an absolute and you calculate the summations. We can do different type of errors. I will tell you another one. You know that I have drawn a line which are perpendicular to this blue line, right? I actually can calculate the line which are horizontal, parallel to my y-axis. And I say that I'm trying to minimize this error. Okay? Or I could draw the line in this form. I could draw horizontal lines. And I could calculate an error which minimizes an error function which minimizes these distances. Or I can define, I don't know, any type of other errors that we have. Now, the reason that we like S-squared error, apart from that in this specific example it brought us to the mean, is that there are lots of mathematical methods which are already have been addressed these S-squared issues, right? So why did we use regression? What was the whole problem in the regression? Yes, we wanted to map our data into an output which is continuous. So we can use this error function to calculate what is the shape of the function that we have. Why do I need to know my fx? Because if I know my fx, then I can put whatever the value is to calculate the output. What is the whole process doing? In other words, in this example, when I give you, forget about the desk line, Eric, I tell you that if I have 600 meters squared, the price is, let's say, 5,000, and if it is 800, the price is 6,000. If the area is 700, what is the price? 600 was 5,000, 800 was 6,000. Now I want to know what is the 700.
5.5.
It seems to be 5,500, 5,500 euros. What we do is practically when we want to calculate and do the regression, if you have a few data, we try to do, what is the term that we use? Do the interpolation, right? Because you know one value, you know another value, you try to interpolate between these values. Now, the next thing that we want to talk in the machine learning, which we don't talk about it in details, because this next topic will be taught in machine learning, in artificial intelligence course, I think, in computer science in details, is neural network. We will talk about neural network, and we will see how the structure looks like, so a little bit, so you get some sort of information, and if you find it very interesting, you can always go and take that course next semester and continue. Now, we don't continue teaching now, so we can stop the camera, but what we will do